As a tutor, I've noticed a lot of students struggle with waves because they really don't understand what a hertz is, and they're just kind of using it without knowing how it relates to meters and seconds. And it's pretty abstract for them, and it can be made a lot more concrete by looking at train cars and thinking about how train cars go by as an observer looking at those train cars. So we're going to be thinking about waves like this, where you've got one cycle or one train car of distance, and comparing one that's got a longer train car and one that's got a shorter train car, but they're traveling at the same speed. So waves travel at the same speed. If we're talking about light, it's going to be in a vacuum, then it's going to be that like 3.0 times 10 to the 8 number. But in any case, we can think about this as train cars. So if you've got a longer train car going at the same speed as a shorter train car, and you're looking at them, the frequency is how many train cars go by in a second. So this is going to be frequency, which is going to be thinking of cycles over time. So if, let's say that we had just like baby math numbers, a c of 10 meters per second for both of these. And I'm looking at the frequency, and I can see that there's a slightly different frequency for the one that's shorter and one that's bigger. So if we go back to this one formula, if this is held constant, if I make my frequency go, or my wavelength go down, my frequency goes up. So if I make the carts shorter, I'm going to see more carts going by every second. So this could be, let's say maybe, do this as red light. So let's say that this has a wavelength of 10 meters. Well, that means that its frequency then is going to be only one train car going by every second. So there's only going to be one cycle per second. And we can do that in the formula here, where we've got our 10 meters per second, and we've got a wavelength of 10 meters per cycle. Typically, it's not written per cycle, but it helps to like think about like a train car as a cycle with the analogy of the waves. So we've got a wavelength of 10 meters per cycle, and this is being multiplied by a frequency of 1 cycle per second. Then if we do the same speed, and let's say we cut the wavelength in half, let's say that the wavelength now is 5 meters per second, how many of these cars are going to go by in a second? Well, it should be 2. You should have 2 cycles per second. So you can see when we think about this in terms of cycles, this term cycles is getting canceled and leaving you with meters per second. Typically, though, we don't use the word cycle here. It's just implied. This is a distance with 1 unit. This is a number of those units that have gone by in 1 second. So when we're talking about a hertz is just the number of cycles per second. So if you've got a hertz of like 10 hertz, that means you're getting 10 of these waves going by every second. If you're like a fixed observer at a fixed point, you're seeing 10 of these go by. So you can imagine how this then relates to waves. A lot of waves in a lot of these problems that I've seen students be given, they might be given the wavelength in meters, but it could also be like something like nanometers, because a lot of visible light will be like 400 nanometers or something. And so you might have to convert it into meters to work with hertz to get something that is in meters per second, right? And This is sometimes it's given in hertz, but I've seen it also in megahertz. So to get this formula to being using meters per second, you should be working with meters and hertz because that's really per seconds. Like it's oftentimes just written as something over time. And because like it doesn't have the word cycle in there, I think people get really lost as to how these things are being related. But hertz is, put simply, it's just the number of times a cycle is happening every second. If you think about the train cars, it's the number of train cars that go by every second. You could imagine having a really short train car that's only 1 meter long, and you're going to get 10 of those going by every second if it's going at the same speed here. Thank you for McLearning with me. Before you go, please check out the following services that I offer with my business. So if you click the link in my videos, this goes to my website. I might be changing it from Podia because I'm no longer doing the interactive videos for sale. I might put those up for free. But most of my other services are linked here. So you can see that I've got like a Teachers Pay Teachers and a Wyzant. The Teachers Pay Teachers has a lot of my assessments that I have for like the NGSS, as well as lessons that I made when I was actually a teacher in the classroom. So I've got quite a few things like CERs and other things on there. If you want to get one-on-one live support from me, either like with science or like working on like teaching support lessons and that kind of stuff, you can sign up through Wyzant. I have a link to there where you can contact me there, and we can schedule hourly appointments. And I've got a few other things on here like a Facebook page and other social media. And if you're interested in getting professional development with me for like a team of teachers, a whole page with information on that. So yeah, feel free to check that out. Thank you.